Hello, hope so you are doing well. This is your final project simulation made on Simulink. You need MATLAB 2021 version and upgrade version. Okay. When you get the file and install the software, then simple you are open goes to the opens and where your file is download, then open your file and you get these simulations. Okay, one by one I am going to explain your simulation part. Here we are two sources. One is PV sources, photovoltaic systems, and other is a wind turbine. Okay, in when we use every when we use the PV system, then we have to connect our PV system with one boost converter and other is a MPPT controller. The full form of MPPT controller is maximum power point tracker. And when you double click on this, then you get the MPPT. And we designed MPPT using P and O algorithms. When we double click on MPPT, then you get the programming of our MPPT here. Okay. On the other hand, here is a array of my solar panels, and we get the PV arrays. This is double click on our PV system, then you get our whole solar system array. And here the temperature of 25 centimeter 25 degrees C, and the uh, diodes irradiance and temperature degrees, then this is a go to connection in Simulink. Go to connection is the connectivity key between two nodes. This connection is the go to for, and here is the go to. We get the value from here. And boost converter, when we double click on boost converter, then you are in the boost converter. You know that in boost converter we have one capacitor and one is inductor, and then our voltage is the boost. But in the boost converter, when we have a IGBT. IGBT is mean that a comparison between two voltages, and comparisons of a maximum and a minimum our voltages. And here is the diode. This diode is using to background protection, and here is the voltage, parallel voltage, voltmeter, and reading of voltages, and this is the two capacitors, and here we get the value of our boost converter. And pulses, why what is the functions of MPPT in our system? MPPT is mean maximum power point trackers produce the pulses is means open the IGBT functionality. On the other hand, we are going to connect our one battery. One battery is connected to the boost converters, because every solar panel systems, first of all, uh, charge the battery, and battery DC. Batteries convert the voltages into the AC. In our home, our employees works on AC supply. No, when we when we use the solar panel system, then first of all we charge a battery, and battery give the input to the inverter. Inverter means that convert DC to AC. Our system DC signal to convert AC signal and AC source. Okay, when you double click on our inverter, then you get the three-level bridge. The three-level bridge is means that you convert your system in a three-phase. First of all, when our system is a distribution level, then our system is a three-phase system. Okay. Now here my inverter is convert my DC to AC signal. When I get the AC signal, then we read the AC voltages here, and this is our three phase RLC branch resistance inductor and the capacitor branch mask. On the other hand, with filters, you know that when we convert the DC to AC, then we need one filter. Why we need a filter? Because we want to get the pure AC signal and pure AC power. Then we connect our system to filter. Here my transmissions convert from DC to AC. Then we connect our step up transformers between the in between our transmissions. So so in our transmissions, when we connect and convert our DC to AC, and after passing our transmission from filter, then we step up our voltages, and then we step up our voltages, then pass from the relay. Why we connect our relay? When if any fault occurs, and if any uh, fault occur in my solar system, then this system is transformed to wind system. And here is my wind system, and we know that wind system is produced AC induced and induced AC signals and AC transmissions. Then we no need to convert this system to and no need to connect a boost converter and inverter. Hope so. You get my point. Wind turbine transform AC transmissions. So we direct connect our wind three-phase signals to a step up transformer and connect to the relay. Why we connect our relay? Because if fault occurs in wind sections, then our systems transform on solar systems, and if solar systems occur fall, then our systems transform to wind system. Okay, here is the connectivity of both our grid section after passing a relay. Then we turn on our home appliance like AC load and motor load. Here we find the voltages on our load, motor load, AC load, and another appliance. If you want to connect, then we turn on our home appliances. That's very cool. And here my control system. Here we get the values of this is the go-to sections and connect our all go-to sections to our grid section. Here we know the power of our solar systems, and here we know the power of our wind systems. No other hands, this here we know the fault status and other current power status. No, first of all, okay, when you get all the appliance, all the appliance. Okay, when we run our simulation, then you saw that the output of our solar power systems and solar power system. Okay. This is a 2%, then our system is there. We get the values, generation of our system, the kilowatt powers, and solar systems in the wind power solar systems. That's very cool project, and I don't have any words to explain more sections here. Okay, if you get the results from the solar power, then double click on grid. Then you get the values on our scope. This is the power section. Voltage is first of all when I will start the solar system is the zero, but according to our relays section and other problems, the voltage increases the rhythmly and power is current is increases and 22 to 20 kilowatt and 25 kilowatt generations. It depends upon the load. When you click on this, then the your graph is stable. Okay, other graph if you want to study, this is the this graph is dependent on kilowatt generation. 0.1 is mean the 0.1 kilowatt is mean roundabouts other words. Peak section here. Okay. Hey, the battery status. If you want to know the battery status, double click on the battery status. Then double click on the converter. Here, you know the converter output, the startup, the battery charge, and then the discharge. And this is the section that here the battery demand and supply voltages. That's great. On the other hand, if you then all the sections here, the three-phase power sections here, the sections of our generation of our PV system and other systems. The whole simulations is working very well. On the other hand, at the load side, you double click on the our system, then you get the output of appliances. If you have any question and if you have any queries according to this simulations and project, you want to connect anyone. Thank you and God bless.